Hello everyone, this is a video lecture for Pre-Calculus, section 6.6, Law of Cosines. So we just did law of sines, now we're doing law of cosines. Here's your formula. Same idea though, we're just basically able to find the sides and angles and all that stuff given any kind of triangle that we have, as long as everything's like opposite like that. And so this is just another formula that we can use. This is a very, I would say it's a very good formula in special cases. That's the point here. It's not like I use it every time. Have we used law of cosines up until this point? No. Have we gotten by without it? Well, yeah, actually. So there's going to be some times that we have to use it, and sometimes where we don't. So we'll just keep going through the sections. Here we go. I'm going to just keep going, I guess. So 6.6.008. I got little a is equal to 131.5. Little b is equal to 58.3. And little c is equal to 159. So let me just draw out this triangle. I got a theta right here. I got my 58.3 right there. Got a 159, and then I got my 131.5. And they're saying find this angle here, theta. Well, if you kind of match it all up, this is actually going to be angle C. So I have what the book would say is a side-side-side triangle. And if we have one of those, we have to use law of cosines. So we're going to just use this formula. So this formula is useful if I have all of the sides, right, and I'm missing one of the angles. Okay, if I had any of the angles, then I would just simply use law of sines and start doing stuff. So this is one of those times where it's appropriate to use it. Okay, let's plug it in. Let's do it. So I'm just plugging it straight into that formula. I mean, I could just have it sitting right there. I got 159 squared is equal to 131.5 squared plus the 58.3 squared minus 2 times that 131.5, the 58.3, it's not a 3, that's still not a 3, and then times the cosine of my angle C, or in this case I guess they're wanting theta, so I'll just leave a theta, I guess, is fine, and solve for theta, solve for that angle. Well, like, I guess we just got a lot of numbers. I'm going to subtract this and subtract this to the other side. Notice I'm saying subtract them to the other side. Not divide yet. And we're going to actually do all this math here in a second. I don't want to round so much. I just want to find it, all out at once here. Negative 2 times this 131 times the 58.3 times the cosine. It's a lot to write out. I'm going to take these numbers here and divide them to the other side. Notice with the negative. And so now I've got cosine of theta is equal to, in the numerator, all this stuff. And this is what I did on my paper. Could you find the decimals along the way? Like, could you find all this numerator stuff beforehand? Probably, yeah. But again, if you're doing decimals, you better write out as many and as much as possible. Okay, like here, I finally did this on my paper. I said, okay, negative 0.29934715555. I mean, I took every decimal possible. To find my angle, I'm going to basically move that cosine to the other side. How do I do it? With an arc cosine. Again, this is just calculator. All of this is calculator. And I would recommend to use the answer button as much as possible. That way you don't have to keep writing all these decimals. It makes it way faster. And so I got 107.418396 degrees. They're not going to need all that. That's a 107. Okay, there you go. So they just wanted that one angle. And there we go. We did it. Use law of cosines. The end. Next question. So 6.6.001. I'm sorry, not 001. It's 11. 011. So this time they give me an angle here of 120. I've got a 10, and I've got a 21. I'm going to label some of these. I got an A, this is a C, this is B, and this is little c. And they want to find little c, angle A, you know how this works, and angle B. Could I use law of sines? See, I'm always going to start with that. If possible, can I use law of sines? No. Because every single opposite, can you see every single opposite, is missing something. That's the difference. That's the key here. You can only use the law of sines if you have both a capital A and a little a, or a capital B and a little b, or a capital C and a little c. I don't have any of those. I don't have any pairs that match up. So I'm going to have to use this law of cosines. Notice that I'm going to have to use it to find a side this time. So I'm just going to plug it straight in yet again. I forgot to tell you something. We'll talk about it here in a second, okay? It's not super important yet. Okay, just like in a lecture, you know, things happen. So here's my formula again. I'm just going to plug it all in straight in. So little c, I don't know what it is. I do know little a is 21. My b is the 10. 21, 10, cosine of 120. All of this is actually just one big number. And so I got 751 in the calculator. How do you get rid of that squares? You square root both sides. Yes, there's a plus and minus, but we know we're only working with physical dimensions here, so we're only going to have the positive. I'm ignoring the negative. I got 27.404379. Again, as many decimal places as possible. There's your answer for C. So we just got C right there. Like here in WebAssign, you could just use 27.4, I'm sure. But you better keep all these because we're going to be using this number here in a second, okay? As many decimals as possible. Okay, so we found this guy to be that 27.4. Awesome. Now, I'm going to ask you to find the others. Can I use law of sines? And yes, because I have a capital C and a little c put together. So now I'm going to use law of sines. Notice that I'm going back to law of sines whenever possible. I ask, can I use law of sines? No. Okay, well then I'll use law of cosines. Can I use the law of sines here? Yes. So I'm going to go ahead and do that. The law of cosines, I would say, is a backup plan. So sine of A, opposite of A is going to be the 21. This is all old news at this point. C is the 120. And then my little c is the 27.404379. In order to solve for A, I'm going to actually multiply this 21 to the other side. We did that once in the last section. You probably did it a little bit more than once because on the homework you have to do it a couple times. But it happens. You just move it over just like what we normally do. To get rid of the sign, to move it over to the other side, you need to arc sine that. And again, I suggest using that answer button as much as possible here because you could just say divide by answer, right? Because you would have that stored in memory, basically, on your calculator. It was like the last result. Just a thought there. So arc sine of all this stuff, and I got 41.57777. Yep, there's 4 sevens. There you go. So there's my A. And lastly, to find B, I'm going to use the 180 rule, just like I have in other sections. So then I had the 120. And I also have this 41.57777. Subtract it all, and I get the 18.4222. There's my last answer. Okay, the thing that I forgot to tell you about, but this is actually going to be important later on. Let me go back to my formula for law of cosines. This guy right here, my formula. Notice that I just have C and C. Like these guys right here are the same letter, right? And then these guys are the other letters. That works for any of the letters. It doesn't have to be just C. It could be, like, here's another formula. A squared is equal to C squared plus B squared minus 2BC cosine of A. Let me kind of just move it out. Cosine of A. Notice that as long as these letters here are the same, you're good to go. And that these guys are the other letters. you know? Okay, so again, and there's a third formula, the b squared, blah, 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 cosine of b. And those are just the three basic ones. If you actually look really hard in the book, or even formula book maybe, you'll see other versions of this where they'll say, well, cosine of c is equal to, and they got some big fraction thing. And it's just a revision of this. I mean, they're just basically taking this and revising it into that same formula. I don't use any of those. I just use this one. I've only known this one, but I do also know that I don't have to use C here. It just so happens that the last two problems we can do that. But you can use any letter as long as those two letters are the same. It should work. Okay, so that's my little statement. Be prepared. Here we go. 66017. This says B is equal to 124. Little c is equal to 161. And angle B is equal to 45, go. Well, here's the thing. It's kind of funny. Whenever they list out the answers, let me list them all out. They have two sets again. Now, I can't remember how many of these double two-set things that you have. I think these are actually capital C's. Sorry, I see the little degree symbol. So those are actually angles there. I don't know how many of these are on your homework. I can't remember, but certainly they are an important topic that we have to talk about. I've talked about this one a long time in the last video lecture, so if you want to go back and review that or whatever, that's fine. I'm just going to jump into this guy as if it's like super fast, okay? Remember my question that can I use law of sines on this? And so just remember that as we go through this problem. So like last time, what we have here is a 45, and opposite of that is the 124, both here and here. And then this is a fixed 161. I'm going to try to find the acute and the obtuse angle versions for, what is that going to be, a C? Yeah, that would be a C in this case. Okay. And when I get C, my angle C, then I can start to put them in the right places and all that kind of stuff. Okay, so can I use the law of sines? And I'm going to say yes. So let's start with law of sines. Again, I am not going to explain this nearly as much as I did last time. If you want a full explanation of what's going on, go back and watch that last one. Because I spent a long time on it. I'm just copying stuff here. To get that sine to the other side, I'm going to arc sine both sides. I don't know if that's canceling them or if that's just moving it over. I've always done a move it over, but it technically is a cancel on both sides. Whatever. Blah, blah, blah. Put this in, and I got 66.6496 degrees. Okay, notice that this is acute. Okay, what that means is what we're dealing with this guy here. We just found this angle. So just like last time on the last problem, this is one of my answers. It's the acute version. This is that acute problem that we're going to be working with. To find the A, I'm going to use the 180 rule. So 180 minus that 45 originally, minus the 66.6496. And I found my A to be a 68.3504. And then to find little a, I'm going to use the law of sines again. I already got capital A, so might as well put that in. Over little a. Let's use numbers that I know for sure. So I'm going to do the 45 and the 124. In order to get little a, multiply, divide. We've done this a whole lot. Very, very familiar now. My handwriting is super sloppy right now. Because again, I've already done this. I'm just doing another one for you because I really like you. There you go. 162.99196, and that's my final answer for the acute. Whew, my hand is hurting. So keep going. Now I want to do the obtuse version, And so remember that I had this guy right here, my acute angle. I'm going to 180 it. If you remember how it works, I got this, and so I got this angle. This is the same angle. I want this one here. So in order to get that, I'm doing a 180. So 180 minus that 66.6496. I know this kind of looks similar. Look, 66 versus 68. I'm using this guy. I'm using the acute to find the obtuse. So 180 it, and I got a 113.3504. Again, I'm probably going more decimal places in my calculations here than what I'm writing down. Just saying. So I found this is my C, if you remember, and then to find A, this is my obtuse, by the way. See how it's more than 90 obtuse. My A then would be the 180 rule minus the 45 minus the 113.3504. Did I draw my last triangle? Oh, okay, yeah. So the obtuse. What does that look like? It looks like this guy. And that's what we just found. Okay, keep going. This guy is a 21.6496. Okay, and then to find little a, well, I guess I'll just do it the long way still. 21.6496 divided by little a, sine of the 45, divided by the 124. 124, was it? Yeah, okay. Same as last time. Multiply, divide. Same thing. There's a lot of writing. Sine of the 45. Super sloppy. I am sorry about that, but I mean, we've done this 4 times now, it seems. And I got 64.69635. That's a side. So that's in units. And we're done. So 1, 2, 3. That's on one side. And then I got 1, 2, 3. That's on the other side. Okay. Notice one thing. Like, go through this whole problem real fast with me, okay? So we had the 2 different sets. I go through law of sines. I do some 180s. I do law of sines. I do a 180. I do another 180. I do a law of sines. Did I ever use law of cosines? I did not. So why is this problem in this section? Here's the thing. If you go and, I don't know, read it, watch it, master it, you know, they got those little buttons at the bottom. If you go and do any of that stuff, it probably will guide you through a version using law of cosines. Great job. But ultimately, it comes down to just getting the math done. I got the law of sines. I know the law of sines. I did the law of sines, and it worked. Next question. So 66030. It wants the area of this triangle that I'm going to draw for you. They have sides 5, 3, and 3. So let's do 3, 3, and 5. And they want to find the area there. Could you go to DuckDuckGo and find the area of an isosceles triangle? That's an isosceles, right? Couldn't you go and find there's a formula for it, I'm sure. Yeah. That's not the point here, okay? Instead, I want to show you a new formula, which we'll be using for this problem and the next one. It's called Heron's formula. Heron's formula. You gotta see Heron's formula sometime in pre-calculus. This is a 2-part formula. It's kind of a little strange. So actually one of my favorite formulas. Area is equal to the square root of s times s minus a times s minus b times s minus c. And then that little s is actually equal to 1/2 times a plus b plus c. Notice, I'm finding the area of a triangle given only the sides. So given that I have the 3 different sides of this triangle, can I find its area? Yeah, just plug it all in. This is a very old formula. This is ancient stuff, but it works. It's really neat, and it's a great formula. Basically, this S is step 1, and that way you can plug it in right here, there, and there. Once I find S, I plug it all in with my A, B, and C, and poof, it just works, okay? Super, super cool. So let's start with my S. If you notice, I got the 5, 3, 3. So 1/2 of 5 plus 3 plus 3. If you do the math, it's 5.5. So this is my S that I'm going to be using there, 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 and there. So my area now is equal to the square root of 5.5 times 5.5 minus 5, 5.5 minus the 3, and then 5.5 minus the 3 again. Put this all at once in the calculator, and I got 4.1457809. That's units squared. It's an area. And there you go. Pretty cool. I really like Heron's. It's a good one. There is another area formula for triangles. It's 1/2 A times B times sine of C. Okay, so notice that's an angle. That's another area formula, but notice that I'd have to have an angle in order to get that. So either could you go and use law of cosines for a minute to get that angle and then plug it all in and do whatever, bypassing Heron's, I guess. I like Heron's. I think it's easy, so that's just me. 6.6.035. This is one very confusing looking problem, okay? So maybe I overthink a lot of this stuff, but it has all these odd shapes, and it kind of looks like a three-dimensional object that's coming out of the page at you and all this kind of stuff. And they say this is a 100 degrees right here. Find the area of this thing. Well, don't think all three-dimensional here, okay? This is just a plain, two-dimensional, flat object on your screen. So how do I find the area here, all the area inside of this? It's just a weird shape. What I'm going to do is break it down by cutting it in half. So I got this half, and then we should be good to go. I don't know what to call this. I guess you can call this X. On my paper, I called it A. It doesn't really matter. I'm wanting to find this distance here, and then I think I could start doing triangle area things with like Heron's or something like that, okay? How do I get this side here, given that I have an angle and two sides on the side of it? Sides on the side of it. It's called a side angle side. Again, we don't really care that much about it. Well, we're in the law of cosine section. Indeed, we're going to use law of cosines. I'm going to say x squared is equal to 5 squared plus 6 squared minus 2 times the 5 and the 6 times the cosine of the 100 degrees. There you go. I guess I can scroll over a little bit. Okay, notice that, again, like I had said earlier, these are opposite of one another, right? X or A or whatever letter you want to call it, doesn't matter, are opposites of one another. So are these opposites? Yeah. And then this is the rest of the numbers, right? This is the other numbers? Yeah. Everything's good. So I could solve for X this way. Like, this is just one really big number. So X squared is equal to 71.41889. Again, don't just leave it like this, because when you square root it, it's going to be way different decimals if you were rounding. So please, don't round. Just say something like square root of answer on your calculator. I've stressed that a lot, because that's a very common problem for, well, students. That means you. And me too. So it's a very common issue. This is not your answer, but it's getting close. I found that this distance in here is 8.45, blah, 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 blah. Again, as many decimals as possible. Now that I have this, I basically have two different triangles. I have this 8.45, I got a 5, and I got a 6. Find the area of that. Let's call this area 1. Area 1. And then I got my area 2. Would be the bottom part, this guy, which is an 8, a 7, and here again is the 8.45. Okay, so that's my area 2. Basically, my total area would be area 1 plus area 2 is my total area, which is my answer. So what I did is I just did Heron's. I did Heron's on both of them. And we already did a Heron's problem. It's very simple stuff. So do Heron's again, add them all up. And here's my answer, by the way. I got a 40.77. So there's your answer. It's pretty simple once you get the idea of what to do. The idea is to cut it across with this law of cosines, and then just split it up into two different triangles, do some Herons, and you're good to go. Okay, last question of the section. I got 66044. This is about planes or jets or boats or some. I think it's boats maybe. And it's a little weird at first, so just kind of hanging tight with me. I got north over here. I got 50 degrees. They say this is 70 degrees. I got 22 miles per hour. mph. That's good enough. This is 23 miles per hour. If I could do an M. Okay. And let's just, I think they're boats. So I want to know the distance between these boats if they start at the same point and they go out after 1 hour. So distance after 1 hour. That's distance between them. So like, you know, this guy and this guy, how far apart are they now after 1 hour? You know what's funny? Like, I'm pretty sure, I can't remember if it's always a 1, but let's just say it's a 1 or a 2 or something like that. This is miles per hour. You got however many hours. So, like, the distance here is, I'm just going to take these numbers here and multiply them. And so I can get my triangle now. So this would be 23, because guess what? 23 times 1 is 23. 22 times 1 is 22. Again, if you're kind of confused about what's going on here, I'm going to use a different color. Let's just say they said 2 hours. Well, then you would have 44 and 46, right? So that makes sense. Again, just depends on what they have for their number. You're just multiplying them. Okay, blah, blah, blah. Let's go back and do this problem. What they're wanting is this distance D here. I don't know, I called it D. And I need to find out more stuff. Obviously, I'm just kind of missing a lot of things. Well, notice I have these angles right here, but I need the angle on the inside, right? Well, the whole entire thing here, that should be 180. Notice that we have like a 90 and another 90 makes a 180, yeah? So I got 180 minus that 50 minus that 70 should give me an angle of 60 degrees. And that's this guy. This is 60 degrees right here. That's this angle between them. Now what? Well, law of cosines. Notice that these guys are opposite of one another. So d squared is equal to 22 squared plus the 23 squared minus 2 times 22 times the 23 cosine of the 60. Put this all in the calculator once. I got 507 for my d squared. So, of course, you know what to do. You square root that thing. And I got 22.5166 miles apart from one another. And that's it. All right. Thank you very much, guys. Have a great day.